Hi all, let us see some problems on arches now. We are about to see some problem on arches. Let us go through the question. A circular arch to span 25 meter with a central rise 5 meter is hinged at the crown and at the springing. It carries a point load of 100 kilonewton at 6 meter from left support. We should calculate the reaction at the supports, reaction at the crown, and moment at 5 meter from left support. Let us see how we can proceed. First, we should find out the reactions, vertical reactions at A and B. How we can find vertical reactions? Either we should take moment towards A or towards B. Here we are taking moment towards A. So VA into distance from A to B is 25. VA into 25 equal to 100 kilonewton load is acting at a distance of 6 meter from A. So 100 into 25 minus 6. From this we can find out VA and VB. How we can find? Total of downward load is equal to total of upward load, isn't it? So 100 minus 76 gives you VB. Now to find horizontal reaction H, let us take moment about the crown, that is C. Taking moment about the crown, we get VB into how much? VB into distance from B to C is 12.5. So 24 into 25 minus horizontal reaction into vertical distance is 5 meter minus H into 5. From that we can find horizontal reaction. Okay. Now, considering equilibrium of left half of the arch, reactions at the crown may be calculated. Okay, so let us consider left half of the arch. Now, we should find out the vertical reaction. So, the vertical horizontal force is 60 kilonewton, and we should find out vertical reaction at C. Okay, C is the crown. So, shear force till the crown. How much is that? 76 minus 100. Okay, shear force till C. 76 is acting upwards and 100 kilonewton is acting downwards. Okay, so shear force at C is 100 minus 76. That is given here as 24 kilonewton. Okay, that is 24 kilonewton is actually, what is 24 kilonewton? This 24 kilonewton is 100 minus 76. Shear force at C. Now we should find out moment at 5 meter from left support. We are about to find moment at 5 meter from left support. Let us take the property of the circles. H into 2R minus H equal to L by 2 into L by 2. In that L is span of the arch, R is radius. Okay, H is the rise. We can find out the radius. Once you find radius, then what is R sine theta? Let us refer the figure once again. You can see that R sine theta, what is the distance R sine theta? R sine theta is from, suppose we are drawing a horizontal line from D, then, okay, this is the horizontal line from D, and that is equal to R sine theta. Okay, and how much is that? R sine theta is equal to 12.5 minus 5. Okay, so that is what we are writing here. R sine theta is equal to 12.5 minus 5, which is equal to 7.5. So from that, we know R here, we can find out sine theta. Okay, once you find sine theta, you can find theta. Now, to find out moment at D, we should know the vertical distance at D, YD. How we can find out YD? Let us again refer the figure. YD, you can see YD is the vertical distance from D to the base of the arch. And how much is that? That is actually from H, we should subtract some part. Okay, that is the total distance is r. From that, total distance is r. Okay, and you know r sin theta. Okay, when you subtract r sin theta from r, you are getting this small distance. So that you can subtract from h to find out vertical distance yd. So that is done here. H minus r cos theta. Okay, this r cos theta actually. So r cos theta is the vertical distance. R cos theta is the, what is r cos theta? R cos theta is from here to here is r cos theta. Okay, so r minus r cos theta gives you some small distance on the top portion. So h minus r into 1 minus cos theta gives you the vertical distance yd. H minus r into 1 minus cos theta. Like that you can find yd. Once you find yd, you can find out the moment at d. Moment at d, how we can calculate? Va into 5 minus horizontal distance into horizontal reaction into yd. Next problem. A three-hinged semicircular arch of radius r carries a UDL of intensity W per unit length over its entire whole span. Determine the reaction and the supports and the maximum bending moment in the arch. Again, you can see the figure. Here UDL is there. Then UDL is acting. The circular arch is of radius r and a angle theta is shown there. So, like in the earlier problem, we can first find out the vertical reactions. First, we should find out vertical reactions. Here UDL is there, so both the vertical reactions are equal and we can find it out. To find out horizontal reaction, what we should do? We should take moment about the crown point. So here it is h into the red height is r, h into r minus VA into r. Again, UDL is acting, so WR into r by 2. So we got the horizontal reaction. Now x is equal to r minus r sin theta. From the figure, you know what is r sin theta and you know what is r minus r sin theta. That is the vertical distance. That is the distance x. Okay, r minus r sin theta is the horizontal distance from A to D. Then y is equal to how much? Y is equal to r cos theta. Then moment at a point at a distance x, Va into x minus hy minus w x square by 2. Va value we know, h also we have found out. So substitute the values. Now you got a equation for mx. Let us substitute, let us differentiate that with respect to theta. So you get while differentiating theta equal to 0. That is, it gives the crown point where moment is equal to 0. Sin theta equal to 0. That is theta equal to 0. Again, 1 minus 2 cos theta equal to 0 means it should be the maximum point. That is where cos theta equal to 0.5 or theta equal to 60 degree. That means x for maximum moment point is r into 1 minus cos 60. So m max is equal to wr square by 2 into 1 minus cos 60 minus sin square 60. Next, we have a problem on parabolic arches. A three-hinged parabolic arch hinged at the supports and at the ground has a span of 24 meter and a central rise of 4 meter. It carries a concentrated load of 50 kilonewton at 18 meter from left support and a UDL of 30 kilonewton per meter over left half portion. Determine the moment, thrust and radial shear at a section, we should take 6 meter from left support. Here again, the figure it is shown UDL acting at a distance of 12 meter from left support, and you can see a concentrated load 50 kilonewton at some distance 18 meter from left support. So as in the previous problems, first we should find out the vertical reactions. First we should take moment towards A or towards B as usual, and we should determine the vertical reactions. Okay. Once you find vertical reactions, take a moment about the crown point and find the horizontal reaction. Here it is. From B, we are taking the moment because from if we are taking from B, the number of loads we should take will be less. If you are taking from A, then you should consider UDL. If you are taking from B, then only concentrated load has to be taken. That way we can find out the horizontal reaction. Then at 6 meter from left to support, you can find out the moment, right? M is equal to VA into 6 minus horizontal reaction into YD. Then at 6 meter, UDL is there, so 30 into 6 square by 2. Now you should take the equation for parabolic arch. Equation for parabolic arch is y is equal to 4hx into L minus x by L square. Okay, we have seen it earlier. Equation of a parabolic arch is 4hx into L minus x by L square. Suppose we are taking at x is equal to 6 meter, then yd is equal to 4 into 4 into 6, 24 minus 6 by 24 square. That way we should find out yd for a parabolic arch. You have already seen how we are finding yd in the case of a circular arch. Okay, so for parabolic arch, you should take the equation directly. So once you find YD, you can you can find out the moment at that particular point. Then vertical shear at D. Vertical shear at D. It is usually how we are finding out the shear force. The same method we have to do. So vertical shear at D is equal to vertical reaction minus 30 is your UDL. So VA minus 30 into 6 meter. Okay. Now the curve is given by y is equal to 4hx into L minus L x by L square. Why? That is a parabola. You find out a dy by dx. Dy by dx is equal to what? Dy by dx is always equal to tan theta. So 4h into L minus 2x by L square. Why? 4h into Lx. Dy by dx of Lx is L. Dy by dx of x square is 2x. So 4h into L minus 2x by L square. Okay. So tan theta is equal to that much. You can find out theta from that. Once you find theta, n is equal to what n is equal to? N is the normal thrust. V sin theta plus h cos theta. What is V? V is the vertical shear at the required section. Okay. And Q is the radial shear. And that is equal to V cos theta minus h sin theta.